Yeah, hi everyone. Welcome to my talk about the predictive back gestures on Android. My name is Tim. I'm a software engineer working at Adesso Mobile Solutions. Just before we get started, we also have a booth outside right behind the JetBrains booth. So if you're interested in any mobile development happening in Germany, just come and grab some popcorn. So what are the goals for my talk today? Basically, we have three things to get done. First of all, I want to quickly go through some history about the predictive back gesture, or basically everything about back animation on Android. Then we want to look at the current implementations and what we can actually do with the new predictive back gesture. And also, lastly, some experimenting with animations and what we can do to actually use this new API. Okay, so a little history. I think this one is pretty familiar to all of you. The first on key down or on back pressed functions introduced in API level 1, basically, where you can just override your on back press function in your activity, do anything you want. For example, ask the user for some confirmation, and then just delegate it to the platform, and it would pop your activity off the stack. However, some side note, this is actually deprecated since Android 13. But we will get to that in a bit and see why this is the case. With Android 3, we got fragments, and I just added it to the list because I think fragments really changed the way we implement Android apps as of today, because we can't rely on the activity backstack anymore, because most of our navigation happens inside our single activity. By the way, this is how Android looked like in Android 3. So yeah, I think we really got a long way. Then we got the Jetpack libraries, and with the initial release with version 1.0, we also got the Android X activity library, and this brought us a new abstraction over the platform backpressed with the on backpress dispatcher. And this will get pretty handy later on, that we have this new abstraction over the platform. And also all the Jetpack libraries, for example, Android X Navigation, will use these on backpress dispatcher and don't call the platform APIs directly. With Android 10, we first got animated gestures. However, this is just a visual indication. Under the hood, it's still the same. So once the user completes his gesture, the on backpressed event was basically put to the animation, to the app, and yeah, it just worked as before. But with Android 13, we got the first glimpse of what the Android team actually has planned for the back navigation, because we got a brand new API, actually a platform API on the Android activity with the on-back invoke dispatcher and the callbacks. And this was Android 13, so I guess you already know this is why the on-backpressed function was also deprecated in the same moment. And with Android 13, we got the, I would say now, final stage of the API with an extension with the on-back animation callback. And this one actually provides us detailed information about the ongoing gesture, and we can use it inside our applications. And also one thing more I haven't added to the slide, but with Android 15, which is will be released later this year, also the on-back invoked callback will be enabled by default, which was previously, I think, hidden behind the developer flag or developer settings. And with Android 15, it will now be enabled by default. So this basically completes the journey of the last 3 Android versions, where this whole back journey started. So what can we actually do with these new predictive back gestures, and how? Well, actually, if you are using the Jetpack navigation library, which I guess many of you are actually using right now, you don't have to do that much. You just have to make sure to upgrade to at least version 2.8 Alpha 02. And this brings in the support for predictive in-app back via the seekable transition. Maybe some folks of you who were in the talk just prior to this have already heard these two terms. And if you look into what this changes, you can see on the right side, we have this new library, and you can see the transition is moved alongside our finger with the gesture. And on the left side, we have the old version where just the transition is played basically from 0 to 100 once the gesture is completed. Okay, yeah, so nice, but what do I actually have to do myself to implement this feature? I don't want to rely on any JPEG navigation libraries for this. And to get a grasp on this, I think first of all, we should quickly look on the API that we get from the Android_x.activity. So this is the on-backpressed callback, and basically these three new functions are of interest for us. We have the on-back started, on-back progressed, and on-back cancelled, which are new functions and basically give you information about the ongoing gesture that the user is just performing. But of course, we are in composed land, so there's also a composable version with the name of the predictive back handler. And this provides you with a flow of events which you can collect. And once this flow has finished and you have collected it completely, then the gesture was completed by the user. And if we get a cancellation exception, so coroutines cancellation, then we can be sure that the gesture was cancelled by the user, and we can then rewind some stuff or do some things with it. So to now integrate this new predictive back handler into our application and actually drive transitions with it, let's try to build an imaginary implementation of a nav host. So you know the Jetpack navigation nav host composable that we all call, and now it's our goal to basically replicate this functionality and integrate it with the new predictive back handler. So what do we need? Let's go through it. First of all, we need to get the visible screen. Basically, we need to know what should be visible right now based off of our navigation stack. This is, of course, framework dependent, but as this is only imaginary, this is the way we would build it. And we can then just pipe this visible screen into the animated content. And the animated content will make sure to transition from one target state to another. And in addition, we can then add the back handler, where we can, if the back action is performed, we can just pop from our backstack. And if we have nothing more to pop from our backstack, then we can just disable the back handler so that the system will receive any back events after that. So this is basically everything we need. And now let's try to take it a step further and introduce the new predictive back handler. First, we shuffle a bit around and actually create our own transition to drive the animated content. This is just so we have more control over the transition, which moves from one state to the other state. Basically, this is the same that animated content would do under the hood if we just call it without this transition. And what this allows us to do is get an old friend back, the seekable transition state, which is actually a quite new API from the Compose library. And if we look into the documentation, it's a transition state that can be manipulated not only by the animated_to functions, but also by the seek_to functions. So basically, we can move this state to a certain point of time and control the progress manually. And this allows us to then use this transition state and put it inside our own navigation backhandler, which is the next step and the next and last step. And this navigation backhandler then uses the new predictive backhandler. So let's go through it, what we need to do. Once this lambda is called, we know, okay, a back gesture by the user has started. So we first need to get the currently visible screen, and we also need to know, okay, which screen should be visible after the back navigation would be completed. So we do this from our navigation framework. Of course, this is still just imaginary. We collect the events that are passed from the predictive back handler, and every time an event is emitted, we just take the progress from the event and basically seek to the progress in time. So we just call seek_to on the seekable transition state, and this will move basically from 0 to 1 in our transition. Once the flow is collected completely, we know, okay, the user has committed the back gesture, so we need to animate any remaining progress. So we just call the animate to with the target state of the previous screen. And of course, we also handle cancellation because the back gesture can also be cancelled. So we need to catch the cancellation exception and then call animate to on the state with the current screen, so that we basically rewind our actions and actually end up at the same point we were before the gesture was started. And now I think it's time to experiment a bit with this new API and see what we can actually do with it. So sadly, I can't show you the live demo. I built a small sample application, but I will provide you the link at the end so you can check it out yourself. So I can only show you some screen grabs. So this is just, first of all, a basic demo to get you a bit of understanding what we actually get from this predictive back handler. So you can see we first of all get the side of which the gesture started. It's either left or right side. The progress we get is indicated by this gradient, which is a bit buggy, but yeah, you can get the grasp, I think. And also the red dots, you can see we basically get X and Y positions for every finger or touch event from this gesture. So yeah, we can basically use this information to drive our animations or our transitions. Okay, let's see what we can do. First of all, if we use our material components, for example, in this case, the bottom sheet, you actually have to do nothing because most of the material components bring this functionality with them. So you can see the bottom sheet, it will shrink when the gesture is performed. And once it is completed, it will just be dismissed. So yeah, nothing to do in this case. But maybe we want to do some custom transitions because our app is a bit more stylized. So for example, on the left side, you can see we could do some clipping with some custom shapes, in this case, like a droplet kind of shape. And we can also reveal the content that would be visible once we completed this gesture. So this is possible because we use the sequable transition state and also and already seek to the previous screen. So basically, animated content is started and it puts the old content into the hierarchy. So it is already visible there. And by applying the correct Z indexes, we can control that the current screen should still be laying on top of the old screen. And also on the right side, you can see that we also can use some runtime shaders. So in this case, for example, we do some shifting with the RGB channels, and you can see that there's some pretty funky effects possible, and all these are driven by our finger. Also, I think this was a pretty nice addition to the talk previously from Rebecca and Doris. So also shared element transitions can, of course, be driven by the back gesture. It's noted that my version is maybe a bit buggy. I think the talk before gave you some more ideas on how you can improve it. But you can see, the shared element transition is driven entirely by our finger. But we can also give the user maybe some more information with our gesture. For example, we are on a screen where it's currently not possible to navigate back. Maybe he has some pending changes he needs to save, or there's any other stuff that prevents him from exiting this screen he's currently on right now. So we could, for example, show some resistance by moving or stretching the content in the opposite direction of his finger. And this is maybe then an indication for the user that, okay, at this point right now, maybe I can't go back. There's some things I need to take care of. And this is also a nice way to use the predictive back gesture. Okay, at this point, I wanted to show you some more implementation details, but if you're interested, we can chat in the later after this talk. So at this point, basically I have a small summary. So I have 3 points that I want to provide you or give to you if you want to use predictive back gesture and create some animations or transitions with it. First of all, of course, if you're using Compose Navigation, update to version 2.8 Alpha 02 at least, so you get the transitions driven by the gesture for free. At this point of time, I think there's no way to customize them. Maybe this is on the roadmap, I'm not sure. So at the moment, it's just your transition is basically played from 0 to 1, and you have no control over, for example, you want to only peak a certain amount with the gesture or some other stuff. But if you are using the Navigation Compose, just upgrade and get nice transitions for free. And if you want to do it yourself, use the predictive backhandler composable from the Android X.activity and also combine it with the seekable transition state. Just short note, I think this API, at least the seekable transition state, is still experimental. Maybe I'm not sure, but when I tested it last time, it was still experimental. So just keep in mind, if you use it in your apps right now, things can change and break. And also have fun, because I think it's really nice to be a bit playful with animations and transitions. And I think this gesture-driven animations really offer some great possibilities that we just hadn't before. Yeah, so at this point, thank you all. And if you have any questions, just hit me up.